So today we are going to start a unit around probability distributions. So this is kind of taking probability to um, to the next level. So we're looking today at random variables and expected value. So first of all, what is a random variable? A random variable is the variable of interest, and it's a numerical value that vary depending on the results of a particular trial. So, for example, you have the probability distribution for rolling two dice you're very familiar with. That you have this table that you can set up where the first die has the chances of the different options, the different outcomes of 1 through 6. And the second die also has the different outcomes of 1 through 6. So your random variable would be the outcome of rolling two dice, and then it has a probability of each of the different outcomes. So the expected value, say you are looking at the sum of two dice when you roll. The expected value is the average of that probability distribution for this random variable. In order to calculate it, you take each value multiplied by its probability, and then you're going to add each one together, the whole thing together. So if your value might be what is the sum of two dice when you roll two dice, and so you would take each value, each sum, and multiply it by the probability of that sum happening, and then you would add all of those up and you would get the expected value, or what you would expect the sum to be, the average sum. The variance, I told you standard deviation would pop up again, not just in one variable statistics, but also in the future. The variance, so the range of values you would expect, you calculate the variance by taking each value minus the expected value that you just calculated it, square it, and multiply it by the probability of that value happening. And then you add all those together and you would get the variance. And if you take the square root of the variance, you get the standard deviation. Notice here that the symbol for the variance is the standard deviation sigma squared. So if you square root that, you would get the standard deviation. Now, this looks like a lot of calculation. Again, you will not have to do this calculation. I will show you how to do that on the calculator. One thing, though, that you need to keep in mind is, say that you transformed the variables in some way, that you multiplied it by a certain number and then added another number to it. So let me give you an example of that. So say you were looking at a lottery game, and each person is given 3 tickets. What would the expected total winnings for 3 tickets be? So you would be multiplying that by 3 because there are 3 tickets instead of just 1. So if you transform it, then the mean of this transformation, you don't have to actually go through and transform all the data in order to find the expected value and the standard deviation. The expected value you can find just by taking whatever you multiplied the original one by, and if you added something to it, you take that, you multiply your original expected value times whatever you multiply all the data by. And then at the end, you would add whatever that extra thing is you add on. For the standard deviation, you take the absolute value, that's what these two lines are, the absolute value of whatever you multiplied it by. That makes sure that you don't end up with a negative standard deviation, and you multiply that by the standard deviation of your original set of data. So if you're multiplying, say for some reason you were multiplying all the data by -3, for your standard deviation, you would multiply your original standard deviation times +3. Addition and subtraction rules. Say you were finding the mean of two things added together, then the expected value would be the two expected values added together. Or they would be, if you subtracted those two values, it would be the two expected values or the two means subtracted. The tricky one here is when you're talking about the standard deviation, you do need to convert it to variance by squaring it so that you're not working with some sort of square root. So if you have standard deviation, you would need to take it back to variance by squaring it. And then if you're subtracting the two, you're adding your two variances. If you're adding the two, you're adding your two variances. And again, that takes care of that whole, you don't really have a negative standard deviation or a negative variance. It's always